Good morning, good evening, good afternoon, good night, Planeteers. It's me, Carl. I've just put together this very short video to try and illustrate some of the common mistakes that were made in the recent online submissions and try to help correct them. So you'll see I've just put together a few slides here that I'm going to show, and we're going to start, as you'll see up there, talking about Monday night's Chelsea-Man U game as an example, and I'm going to bring up a few other things as well. And to help me out, what I've also done is invited my evil twin to help. Yeah, whatever. I mean, yeah, I'm going to help. Yeah, he's bundle of joy, right? But anyway, using him and some temporary slides, I'm just going to have a go at, showing some of the problems. So the evil twin, he's going to show what not to do, and then I'll have a go at showing what to do. So the first one where we had some common mistakes was with the overview slide. Nearly everybody now has got it down to the 3 key points that they're going to tell in their overview slide, and that's great. And I'm really happy that everybody's doing that. But the difficulty is in then what do you say on that overview slide? And so my evil twin, let's give him a go at how not to do it. It's my overview. It's the overview. In the overview, you can see that in the talk, there's going to be a background. Then after the background, I'll talk about the game. Then after the game, I'll talk about conclusions. You see, what Evil Twin did is he just read the slide. But we can all read. Everybody's read the slide. That's not doing any good. So what you should be doing on this slide is actually saying that one paragraph that you wrote, which sums up your talk in one short paragraph, right? We did that in Cape Town, and just highlighting where each one of these points comes into it. So on this slide, what I could do is I could present it like this. I would say. So, in overview of the talk that I'm going to give you about the Chelsea-Man U game, what I'm going to start by doing is to just give you some placing background for those who don't really know about soccer. And it turns out that Chelsea and Man U, will find out, are two of the biggest clubs in the competition, and that the managers are two of the biggest managers. What made it even more exciting was that the manager, who is now manager of Man U, was actually the manager of Chelsea last season, and it's one of his first times coming back. And the FA Cup, the competition, we'll see, is one of the oldest in the world. So it's set up to be a fascinating game. And then I'll go on and tell you about the game. And in principle, what we're going to see is that for most of it, it was very even, but then Man U's Herrera got sent off, and this changed it. And we're going to look at the various ways that a sending off can change a game. And that's going to bring us to what happened at the end. Well, I'm not going to spoil that for you. Let's find out. Okay, so you see, what I'm doing with the overview slide is I'm giving an overview of the talk. Okay, I'm using those pointers to guide me through how I'm overviewing the talk. But I'm not just reading the points. So what I want to see you guys doing when you bring up that overview slide is to tell us that summary about what's going to happen. Remember the old adage, right? The thing that I said in Cape Town, that when you're giving a talk, what you have to do is tell them what you're going to tell them it, and then tell them what you've told them, the conclusion at the end. So I want to see everybody doing those 3. Moving on to another important one. We've got the hierarchy of models slide, and so once again I'm going to invite the evil twin to just show how we can do this badly. Alright, hierarchy, models, yeah, our talk's there, innit? That's our talk. Again, I hope you see that evil twin isn't adding anything to what's on the slide, just highlighting that our talk's there isn't the purpose of putting up the slide. It doesn't do anything. The hierarchy of models slide gives you your opportunity to summarize the whole course and show where your talk fits into it. So if and I'm now moving on to using the origins of life as an example. If we were doing the origins of life talk, what we would show, we would put this slide up and we can say, Okay, here's the hierarchy of models slide. We've seen this slide many times before in the course, but what I want to do is I want to use it just to show you where we've got to. So you might remember right at the top of the slide up there, we go back to section 1. That was now right at the beginning of the course. We started by posing the question, why is Earth habitable? And to answer that question, we've built a series of models that are getting increasingly complicated. And we saw with the bare rock in Not Too Hot that the Earth would be far too cold, and then we added an atmosphere, and we found that with an atmosphere the Earth would be far too hot. We needed the atmosphere to move, we needed an ocean, and we needed the past. And we've added all of these things, and right now you might think that our model would work because we've got oceans and atmospheres and paleoclimates, and we've thought about all of those, and this physical model of the planet you think would be habitable, but it's not. And this is where we come in. This origins of life first adds these living organisms into the model. And as we're going to find out as we then progress on beyond that, life, it turns out, is essential for explaining how Earth is habitable. How amazing. Let's go on. Okay, maybe Carl was a little bit over the top with that explanation, and obviously, evil Carl, you can't trust him at all. But the point is, you've got to put some passion into it, and you've got to use that as your chance to give the summary of the course. So the next and last thing, and probably the most difficult one, those two are quite easy, I think. It's just a case of repackaging the way that you present those two slides. The next one is the linking of the slides together. Too often, the story that you're trying to tell isn't coming through because each of your slides is being treated as an individual bit of science. And the science that you say on that slide is not necessarily wrong. It's fine, but it's not making the story link together. And I've just got 3 slides to present here on the origins of life. To show how that is. And so, by the way, once we've got into this talk at this point, we've already come through religious beliefs on the origin of life, and then how scientists have tried to tackle the question, evolution, how we know that all species come from one original species, and so then that brings us to the question, where did that one original species come from? And so we're now going to go on to thinking about how did that one original cell that we know all organisms come from evolve in the first place. And I'll hand over to Evil Carl to have a go at how not to do it. The next slide is abiogenesis theory. Abiogenesis theory is the theory whereby life comes from non-living things. The first cell could come from non-living things. This is an experiment. In this experiment, they put in things and then they got amino acids. The next slide is primordial conundrum. The primordial conundrum says that DNA codes for proteins and proteins code for such processes. Could they have occurred simultaneously? Probably not. It's a chicken and egg paradox. The next slide is RNA World Hypothesis. RNA World Hypothesis says that RNA can code for proteins, but also can act like a protein. It acts as a gene and an enzyme. So you see, in Evil Carl's version, each slide is like an independent thing that doesn't relate to the story that you're trying to tell. And lots of the science, well, he didn't say very much, but some of the science that he did give was really useful, but it wasn't linked into the story. So, to give it a go properly, you would do it like this. Remember our background again. We've just got to the point where scientists are thinking of modern theories on how that first cell might have arose. So then you say, we've been thinking about scientific theories on how that first cell might have arose. One of the first scientific theory on this is called abiogenesis. And this is the idea that the molecules of life can arise from non-living things in order to form that first cell. And abiogenesis as a theory was supported by a very important experiment which is shown on the screen. And this very important experiment was that of Miller and Urey, and they showed that some of the building blocks of life, called amino acids, and these make proteins, were able to be formed by reacting together the primordial oceans, a mixture representing the primordial oceans. But then after that, DNA was discovered, and we realized that DNA is the code for life. And something came up called the primordial conundrum. The primordial conundrum relates to our last slide because it shows us how abiogenesis is very unlikely to have happened. And this is why. Because for the first cell to arise, you need two things. You need both the DNA to code for the proteins that make the cell happen and that run the cell and do the reactions, but you need the proteins to read and reproduce the DNA. Both of them happening at once seems really unlikely because they both need each other. It's a chicken and an egg style paradox. So although Miller and Urey in the previous slide showed that amino acids are produced from non-living things, that doesn't help us because we haven't got the DNA to complement it. However, there is another theory on the origins of life which proposes to solve the primordial conundrum. This is called the RNA World Hypothesis. And this is because RNA is a very unusual molecule. We have it in our bodies nowadays, and it can perform two functions. It can act like a protein or it can act like DNA. So thus, it could possibly have been the first molecule to do both and solve the primordial conundrum. The problem is the lack of evidence for it. That the Miller-Urey experiment didn't make RNA, it made amino acids. So we're still not sure which of these two theories is the correct one. Okay, that's that one. One last thing, whilst I remember, and that is graphs. Graphs are really important in scientific talks, right? They are our bread and butter. They're actually, how we show the data which is going to prove our point. But that means that it's also really important that you introduce graphs properly. Let's have Evil Carl just to show what not to do. Yeah, so that was a graph in it. Yeah, it's a graph. Shows temperature. So you can see clearly that Milankovitch on that side, and then on the other side there isn't, and so I've explained it. So no, Evil Carl, you haven't explained it, and that's the whole thing. What I want you to do when you put a graph up is you have to explain it. You have to describe it to such a level that somebody who can't see the graph could understand it. So when I put a graph like this up, what I'm going to say is something like this. This graph shows the last 60 million years average temperature record on the planet Earth. On the x-axis, we have time going backwards from today on the right-hand side to 60 million years in the past on the left-hand side. On the y-axis, we have the average global temperature. Remember, that's just an average for the whole Earth. And we can see that the blue line is what's showing temperature. Obviously, on this graph, there's no more than a blue line, but still, you must say what the different lines mean. How was the blue line reconstructed? Well, remember in our talk earlier on in paleoclimates, we learnt about proxies, and we learnt that delta oxygen isotope is a proxy for temperature. So these graphs have been reconstructed using ice cores and sediment cores, where we dig back into the past, and then the proxy for, of delta at 18 is used to reconstruct the temperature. And by the way, we know how far it is in the past from isotope dating. So from that, what we can see on this graph is that there's a big divide around 3 million years ago. Before that, temperatures were warm and stable, and after that we get these oscillations. Now, we just learnt about Milankovitch cycles and how they change the amount of energy that the Earth is receiving. So we can now explain this half of the graph from 3 million to today, because The amount of energy the Earth gets changes, and that changes the temperature in these oscillations that you see going on. What we can't understand from what we've learnt is what happened before that, and that's coming up in the next exciting core lecture. Okay, so that's about it. It applies to any graph or chart. When you put it up, please make sure you explain what you see. All right, that's all from me. Yeah, whatever. I didn't enjoy it. I don't care. And I guess that's all from him. All that remains to be said is good luck with redoing your core talks, Planeteers, and I will see you at the Habitable Planet workshops.